Hey everyone, so I want to give you a breakdown of 3.1, which is solving two-step equations. So for this one, we start in a new standard, which is A.REI 3, solving equations. And in this section, we'll learn how to solve equations using inverse operations. Okay, so the definition of a solution is a value that makes an equation a true statement. Right? In other words, when you substitute the solution in place of the variable, the values on both sides of the equal sign will be the same. So when you substitute, let's say we have an equation and we have verified that x equals 7 equals the solution. All we have to do is substitute it in there. So 4x becomes 4 times 7. We substitute x for 7. And we get 28 plus 11, which is 39. And we do it on the other side, right? Substitute x for 7. 2 times 7, 14. PEMDAS, 14 minus 1 in a parentheses first, 3 times 13, 39. So both are the same, so they are equal, right? So 7 is a solution to this equation because it makes it true. In order to solve equations, we must use one or more inverse operations to isolate the variable. That's the whole goal, to isolate the variable. An inverse operation that reverses the effect of another operation. So like your inverse of addition, subtraction, inverse of multiplication, division, right? Inverse of squaring, square rooting, right? It just undoes the operation, whatever it is. Okay, and then we talk about algebraic properties of equality. So there's 4 of them we're going to go over. So addition property of equality, subtraction property of equality, and multiplication and division. So add this to your notes in here. So if, we'll go over the first one, if A equals B, then A plus C equals B plus C. So you notice A equals B, A is the same, B is the same. All we're doing is adding C to both sides. So in other words, this property allows us to add C to both sides and still have equality. So for instance, right here we added 5 to both sides, it still be the same. Because 4 times 3, 12 plus 5, 17. 2 times 6, 12 plus 5 equals 17. The subtraction property of equality. So same again, A equals B. And all we're going to do is subtract C to both sides. So in other words, this property allows us to subtract C to both sides and still have equality. For example, given 6 times 3 equals 2 times 9, right? They're both 18. If we subtract 5 from both sides, so we have 6 times 3, subtract 5, and then 2 times 9, subtract 5. It should still be the same. Right? So you have 18 minus 5, which is 13, and then 18 minus 5, still 13. So that works. Okay, multiplication, same thing, right? So addition, you can add C to both sides. Subtraction, we can subtract C to both sides. Multiplication, we can multiply C to both sides and still have equality. So we have our C, we multiply C to both sides. So example, 6 plus 1 equals 2 plus 5. They're both 7. If we multiply both sides by a number, 3, so we have 3 times 6 plus 1 and 3 times 2 plus 5. So we still can do PEMDAS on each side, and it still should be equal. 6 plus 1, 7, which is 21. And on the other side, bring down the 3, get 2 plus 5, 7, still 21. So they're both equal. Division, property of equality, same thing. So in other words, this property allows us to divide by c to both sides and still have equality. For example, given 5 plus 9 equals 11 plus 3, they're both 14. If we divide both sides by 2, so we divide this side by 2, divide this side by 2, should still have the same answer. So 5 plus 9, 14 over 2. This is 14 over 2, 7 equals 7. They're both the same. Okay, so those are the 4 algebraic properties of equality we're going to focus on. Add c to both sides, subtract c to both sides, multiply c to both sides, and divide by c to both sides. Simple example, we want to solve x minus 15 equals negative 40. So you always look, where is the variable, right? So the variable is on the left side. So you want to get rid of that constant right next to it, negative 15. So we're going to add 15 to both sides, and we can do that by the addition property of equality to make it equal. So bring down the x. Negative 40 plus 15 equals negative 25. And that's our solution. Example number 2, x over 4 equals negative 12. We want to get rid of the divide 4. So the opposite of divide 4, which is multiply by 4. And we must do it to both sides to cancel out. Right, so our 4 is going to cancel because we multiplied it. Bring down the x, and we get negative 12 times 4 is negative 48. And that's our solution. Okay, so our solving two-step equations, we are going backwards. So order of operations, we do PEMDAS. Solving equations, we just go backwards, right? Which is SADMAP. So SADMAP is solving equations, we're going backwards. Subtract and add first if you can, divide and multiply, then we do our exponents, and then parentheses. You're just going backwards, PEMDAS, right? To step to solve equations, first we simplify if we can, like distribute combined like terms. If needed, then we get the variable on one side, if it's not already on one side. And then step 3 is we follow SADMAP to isolate the variable. We're going to try to subtract and add first, divide or multiply, and then find the inverse of the exponent if needed. And then we do what's left in the parentheses. Okay, so we got two-step equations. So whenever you have two steps, we're always going to look, where's the variable? So the variable's on the left side. So we want to get rid of this plus 20 right next to it. We want to get rid of the constant first on the variable side. So we're going to do the opposite of plus 20. We'll subtract 20 to both sides. And we get negative 5x equals 60. Then we get rid of that times negative 5. So we divide by negative 5. And we get x equals negative 12. Example 4. Same thing. We identify where's the variable. Variable's on the left side. So we get rid of that constant on that side. So negative 8. To get rid of that, we add 8 to both sides. To get rid of the minus 8, bring down what we have. Then we're going to divide by 1/3 because it's times by 1/3. So divide by 1/3 to both sides. Remember, dividing by 1/3 is the same as multiplying by its reciprocal. Right? Keep, change, flip. You're going to multiply 7 times 3 over 1. The reciprocal 1/3 is 3 over 1. And we should know this. So 7 times 3, 21. And then you just make over 1. Multiply across. 1 times 1, 1. 21 divided by 1 equals 21. Another way to look at it is you can just multiply both sides by the reciprocal. If there's a fraction, multiply by the reciprocal to both sides. And that will be kind of a shortcut to get rid of our fraction. And it's 7 times 3, 21 over 1, 21. Fill in a blank with one word to complete each sentence. To solve an equation, use inverse operations to, okay, what's the goal, right? What are we just trying to do with our variable? Right there. We use inverse operations to isolate the variable. So we want to isolate the variable. A solution to an equation is a value that makes an equation a, look at what we had in the beginning, right? So solution is a value that makes an equation a true statement. So it makes it a true statement. Okay, reflection. So the four algebraic properties of equality are, and they're given right, in this table. So four properties of equality. We have addition property of equality, subtraction, multiplication, and division. So those are four properties of equality. So you're just going to add that in there for your four algebraic properties of equality. Write a brief 1 to 2 sentence summary about why these properties of equality are important and or what they allow us to do. Okay, so the whole purpose of having these properties of equality is we can solve equations, right? It's always your both sides. Add 2 to both sides, divide 2 to both sides, square root to both sides. You always hear both sides. That's the properties of equality coming into play. Right? So that's the whole purpose. In order to isolate the variable, we must use the properties of equality so that we can simplify it, isolate the variable by doing operations to both sides. So you write that in here. Make sure you turn that in. Okay, homework. Do some examples. So we got two riddles that we need to figure out. So books never written. And above it, title books never written. Decode the names of the authors. You can solve each equation below and find your solution in the code. Each time a solution appears, write the letter above it. Okay, so letter A. So we got 23 minus x equals 13. So we're gonna identify where is the variable. So the variable is on the left side of our equal sign, right? So on the left side, so you want to get rid of that constant first. So here's a constant. We're going to get rid of that. We're doing the opposite. So that's a positive 23. We're going to subtract 23. And we must do it to both sides to keep it equal. So 23 cancels. Then we're going to bring down negative x. Right? We bring down everything. That's a negative x. And then 13 minus 23 is negative 10. Then we have a negative x equals negative 10. So we got to get rid of that negative. We want it to be positive. So we treat this like a 1, right? It's negative 1. So we divide by negative 1 to both sides. So we get x equals 10. So whenever you have a negative x, it's divided by negative 1 or multiply by negative 1. Same thing. But we want it to be a positive 10. So our positive x. So our x has to be positive. Okay. So we got 10. So 10 was A, right? So we look at where's 10 in our riddle. It's an A. So A, if there's more than one, just keep putting it in. So there's two 10s, we put two A's. Okay, part V. So now we look at our variable is on the right side. So we want to get rid of that plus 5, the constant on the right side. Right, so we subtract 5 to both sides. So get rid of that plus 5. Bring everything down. 9 minus 5 equals 4. And then we bring down the 1/4 x. And then we want to get rid of that times 1/4. So we have to divide by 1/4, which is the same as multiplying by the reciprocal of 1/4, right? Keep, change, flip. So we're going to multiply by 4/1 to both sides. So get rid of that 1/4. Because a 4 is going to cancel out your fraction. So we got 4 over 1, multiply it across. We have 4 times 4, 16 over 1 equals x, which is just x equals 16. Then we look for it on the top, and that's letter V. So 16 is a V. Okay, let's do a couple more. So letter P. We identify where the variable's at. Variable's on the left. So we're going to get rid of that constant plus 2. So we're going to minus 2 to both sides. In our middle. Then we bring it down. We got negative 9t. 2's cancel. Equals 56 minus 2, 54. Then we have a letter next to the variable, our coefficient. We just divide by that coefficient. Negative 9. So we're dividing. So we got t equals negative 6. Okay, so keep in mind, whenever we have the variable in front of the t, we divide it. Okay, we're not subtracting, we divide it. So whenever it's in front of, next to it, we divide, and we get our answer negative 6. In the riddle, right, negative 6 is P. Is to T. So letter T. So here's our variable on the left side. We want to get rid of the constant, 12. So we get rid of that. We do the opposite. So it's positive 12, so we minus 12. Both sides. Here's our middle. That's going to cancel. Bring down what's left. So we get negative 5u equals negative 48 minus 12. It's negative 60. Then whatever's in front of our variable, right, our coefficient, we divide it. Negative 5, both sides. And we get u is equal to 12. Okay, so u 12, and that's letter T. So 12, the letter T. Okay, and you keep going till you finish the riddle. It should make a riddle. If it doesn't make sense, you did something wrong. Right? It should make sense in your riddle. You got Khan Academies to practice. You are assigned those. Google Classroom, also Khan Academy. So work on those, get those done. Ask questions if you got questions. All right. Okay, guys. Till next time. Bye.